Okay, so this is problem 8.6.29, and they ask us to find the partial fraction decomposition, and then they're giving us a negative 6x squared minus 24x plus 36 over x cubed plus 12x squared plus 36x. Okay, so when you're doing partial fraction decomposition, the first thing is you want to take a look at the denominator, and you want to make sure that the denominator is factored fully first. Okay, so if we go ahead and do that, there is a greatest common factor of x in the denominator, and you'll probably notice that the numerator actually factors. You could take a 6 out, but we don't really care about that. In terms of partial fraction decomposition, we're just working with the denominator here. Actually, we do care about it if it's going to reduce into something where these would cancel. Let me look at it. But it doesn't look like it's going to do that. So, okay, so if we pull out an x in the bottom, then we're going to have x squared plus 12x and then plus 36. Okay, and this right here is a trinomial. If we factor that further, we're going to get, you can use trial and error or the AC method, whatever you prefer, but it's going to factor into x plus 6 and x plus 6. Okay. All right, so this is actually a repeated factor right here, this x plus 6. So I'm going to rewrite this so that we can see that. I'm going to rewrite that as x times x plus 6 quantity squared. Okay, so now there's 4 different cases when we're dealing with partial fraction decomposition, and you have to identify in the denominator which factor is which case. And so this factor right here, just the singular x factor, is just case 1, where basically we have a linear factor that's not repeated. Okay, so the way that we set that up with partial fraction decomposition is the numerator is just going to be any variable you want to let it be except x. So I'm just going to let it be capital A, and then over the x to the first power. This right here is case 2, where we're talking about we have a repeated linear factor. So when you have a repeated linear factor, the numerator is just going to be singular, it's just b, over x plus 6, and then you have to do it again over x plus 6 squared. Okay, so this is the partial fraction decomposition setup for this, and I'm going to take away that equal sign because now we're just looking at this equation. And then what we want to do at this point is try and solve this for the a, b, and the c to figure out how this would decompose into this particular fraction composition right here. Okay, so in order to do that at this point, what we're going to do is we're actually going to multiply both sides by the LCM, and that LCM is this right here, this x times x plus 6 squared. So I'm going to multiply both sides by that. Kind of running out of room. Okay, so over here, these are going to cancel, and we're left with negative 6x squared minus 24x, and then plus 36. Now over here, it'd probably be easier if you write this out. You can see more clearly what I'm doing. It's not very clear right here. But we have this x times x plus 6 squared, and it's multiplying each of these pieces. So when I take this and I multiply it by the a over x, the x's are going to cancel, and I'll just be left with a times an x plus 6 squared. And then when I take the b over x plus 6 and multiply it by that, so remember you're actually distributing this, it's multiplying each of these pieces here. One of the x plus 6's is going to cancel, so we'll be left with b times x plus 6. And then when I take c over x plus 6 squared and multiply the x plus 6 squareds, will cancel, and we'll just be left with cx. Okay, now at this point there are several ways to solve, there's 2 ways to solve this at this point. You can either multiply this all the way out and then set the component pieces equal to each other, or you can do what I call the let x equals method, where you let x equal certain values and then you set up a system of equations for a, b, and c. So when I look at this problem, it looks to me like the let x equals method is going to be the easiest. It may not be. Sometimes you just have to try one of the methods, and if you hit a dead end with it being too difficult, then you need to try the other method. So I'm going to go ahead and use let x equals, and I'm going to let x equal a -6 to start with. Okay. Now, the reason that I'm choosing to let x equal -6 is because if I do that, it's going to zero this out and it's going to zero this out, which is going to allow me to solve for c directly. Okay, so that's nice. That's what I want to do to start. So what I'm going to do is everywhere there's an x, I'm going to just plug in -6. So what I have is this -6 right here times x squared, so that's -6 squared, minus 24 times -6 plus 36. Okay, so that's just plugging -6 in right here for the x's. And then over here, when I plug -6 in, this becomes 0, so the a term goes to 0. This becomes 0, so the b term goes to 0. And if I plug in -6 here, I just have a -6c. Okay, so this is nice. This is solvable. All right, so let's do that. I'm going to grab my calculator. So we have a -6 squared, which is 36, and then times 6. So that is 216. So this is -216. And then we have 24 times 6, and there's two negatives in a row, so that's plus 144 plus 36 equal to -6c. All right, so let's just add this. 144 plus 36. I'm going to subtract 216 and I get a -36. So this equation becomes -36 is equal to -6c. And then if I just solve for c here, I'm going to divide by -6. So c is a positive 6. Okay, so that is our coefficient that's going to go in the numerator right here when we go to reassemble this partial fraction decomposition. So we found c. We still need to find a and b. Okay, so now what I'm going to do is I'm going to continue with let x equals. And this time I'm going to choose to let x equal 0. And the reason that I'm going to do that is because if I let x equal 0, that's going to zero the b out, and it's going to zero the c out. So I'll actually be able to solve for a in that way. Okay. All right, so let's see. Okay, I'm just going to stick it to the side here. All right, so we're letting x equal 0. And I'm again plugging x equals 0 back in for x in all of these locations. Okay, so let's see. Oh, there we go. Okay, so that's going to give me, when I plug it in here, it's going to give me 0. Plug it in there, it's going to give me 0. And I'm left with just the 36. On the other side, it's going to zero out the b and the c. But then if I plug in 0 for x here, I'm going to have 6 squared times a, so that's 36a. Okay, so I didn't really write all that out, but let me just do it again. So if you plug in x equals 0 for the x squared here, you've got 0 times -6 gives you 0. Plug it in there, 0 times -24 gives you 0, so you're just left with 36 on this side. Plug in 0 over here, 0 times b times anything there is just giving you 0, giving you 0. Plug it in here, and you get 36a. Okay, so if we divide by 36, then we get a is equal to 1. All right, so all we're left with now is to find b, and we no longer have a value that we can choose that will give us 0 here, that will zero these out and allow us directly to solve for b. But that's okay because we already have a and c. So what we can do is we can just choose any other value for x and plug that in, and then we can plug in the a and the c values that we found already, and then we'll be able to solve for b. So the easiest thing to let x equal is to let x equal 1. If let x equal 1. If you haven't already let x equal 1, then that's just going to be the easiest thing. So let's do that. So when I plug in 1 here, I get a negative 6 minus 24 plus 36. It's going to be equal to a times 1 plus 6, that's 7 squared, plus b times 1 times 1 plus 6, which is 7, plus c times 1. Okay, so now what I'm going to do is I'm actually going to plug in the a and the c that I have already solved for. So this over here, this is negative 30 plus 36, so that's 6, equals my a is 1, times 7 squared is 49. I'm looking for b. And then the c that I found was, what was c? Positive 6. Okay. All right, and we're just solving this. So, this is, if I subtract 6 from both sides here, I'm going to have 0 is equal to 49 plus 7b. And then I'll just do this right here. Okay, so 49 plus 7b equals 0. If we just subtract 49, and then you have 7b equals negative 49, and then divide by 7. So you're going to get b is equal to negative 7 there. Okay. Now, remember that with partial fraction decomposition, you're not done until you reassemble your fraction. So what we need to do now is we actually need to take the a, b, and c that we solved for, plug it back into this fraction, and that's actually our answer. Okay. So the answer that you would input into the computer, or if you were doing this on a test that you would give me on a test, would be 1 over x. That's with our a equals 1, plugging that in. We found b to be a negative 7, and then we found c to be a positive 6. Okay, so that right there is our partial fraction decomposition for this particular problem. Okay.